Sir, your voice is not audible.
Oh, sorry. Now I think I am audible, right?
Yes, sir.
Yes, sir.
Yeah,
Yes.
yeah. Okay, thank you. Now coming quickly, these slides we have already talked. What I talked in these slides, I told that sum of, if it is a random variable, sum of the random variable is also a random variable and normal. If it is a normal, what I told, I talked about, you remember that child birth weight. If I take two child and so there is some 10,000 child is there, and I want to know what is the addition of the two child, weight of one and weight of two. But you see, if there is a very big population, I can take any two, na? So this any two sum will itself be a variable. It is also not a constant, because I can take either this one and this one. I talked about that. And this sum itself is a new distribution, and that it will have a mean will be how many you are taking, n number of. For example, I'm taking two child, if you make three child, so this is n mu, variance is n sigma square. If I'm going to average, if I'm making an average of n, then the mean is mu, variance is sigma square by n. Please keep in mind these two things we discussed. Now I'll be little moving faster over here. These things we already talked, nothing new here. This distribution I'll come back little bit late. Okay, some small. Now this is the part we are really interested with. What is this? First I'll talk what is the use of this. This is known as interval estimate. What is the use of this point? Let me come, I'll just one slide I will add. Okay. Interval estimate means you are replicating something, so coming into more practice. For example, you are doing some, in our last class we started, now we are measuring the weight of mice after some treatment, and I am getting some 100 mice, for example, we are doing 100. Why you are doing these things? And you are measuring the body weight. For example, this is 50, this is 55, this is 60, this is 59, this is 58, like that going on. What you can do from this is your experimental data, and that is called sample, right? What you can do, you can only talk about what is the average. When I'm talking about sample, I will say like this is called average of sample, right? X bar. And we can also find out standard deviation, that we can always find out. So these are called sample, mean, sample, standard deviation. Please understand my point carefully. When you do any study in lab, your sample mean and sample standard distribution is only used for you, for your study. It is not useful for wider audience. Please try to understand how I am relating. This is very important for anyone. When you do any study, if I tell only about sample mean and sample standard deviation, that is only useful for your study. Nobody will be interested. There is no message with that. But if I say, no, wait, this is a sample coming from a very big population which you cannot see. And from this information, from sample information, if I can speak on the population, I hope you are getting my point clear. From this data, if I can speak on the whole mice population, which I have not included in my study, somebody might be doing, and if I can speak on the population something, then that is really interesting. So for example, I'm getting 50, 55, 60, 65. If I ask you what is the mean, is it a single number or you will take something else? It will be single number, right? Average of these, for example, 100 values are there. If I make an average, what you will get? A single number, maybe some 58.99, like that only you will get. But we are not happy with this because you are talking about only your sample. You are not talking about anything on population. That means I need to know that if this population has a mu of that one, I don't know, but it is having. So from my sample, can I talk about the population part? Or reverse way, if I know the population has having a mu, can I talk about the sample? So you need to understand that no, it is not really possible to talk about mu exactly. But if it is possible that I can tell about the population plus minus some range, if I can say that this will be my population expectedly, then that is called as the mean distribution, and we are putting a interval of that. So that means from sample I will talk about population, and with some guarantee will speak. So that derivation part I am just going to talk about. So from sample about population, the purpose of whole study is from sample what you are doing in a lab, how can I use this information to speak about population? Because if you speak about population, the whole audience, any researcher will be interested on this. Anyone is interested on this. But in this study, only you are interested because you have done it. So this point is very important starting point for understanding future things. I hope this point is clear to anyone and everyone. This
Yes, sir.
point is clear. Yeah, okay. So that way we are going to proceed now. How can I get that? So now I'm coming to presentation so that it will be more easy. And that is called interval estimate. Okay, how does it start? Now I'm talking. Assume x1, x2, xn is a sample from a normal population having unknown mean mu and known variance sigma square. What I am talking, going back. I am telling, just a second. I'll just remove it and I'll redraw once again. Now coming to a point, and okay, fine. Assume that I am having a very big population, whose mean is mu. Population thinks I will use mu, and variance is sigma square. I am telling that this I don't know. Normally we don't know, it is unknown. Ideally, the populations, this is also ideally unknown, but assume by God's grace you know it. I will talk about this, why I am telling God's grace. You assume that we know it. Just assume. It is not correct. I'll come to that point later on. And now from this population, I am taking some 10 sample. Randomly 10 things are coming into my population. Because your mice, when you are doing a study, from this population, some 10 sample is coming. Na? So what I am trying to say, that I know x1, x2, x3, these are my sample coming from a population. I don't know what is the mean of the population, but by some miracle, I know variance. And I will show you how the miracle part will come into picture. This is really, practically, this is not true, but I am assuming that are you getting my question? That there is a population. I don't know their mean. It is true. How do you know? For example, whole India, there is some few crore of the child is there. If I am telling the average age of the child is 9 years or like that, this will be very difficult to know. So I am telling that mu I don't know. You are also agreeing, yes, mu we don't know. I am telling variance I know. Variance, how can I know? If I don't know the sample exactly, understanding the variance is also not possible. But for time being, you assume this is correct. Now, if this is correct, I am now going to take some 10 sample, that's all. From this 10 sample, I will go and tell you what is the value of mu I can project. That is my objective. So now, if this point is clear, coming into this point here. So what I am telling, that x1, x2, x3, xn is a sample from a normal population having unknown mean of mu that I want to find out, and known variance of sigma square. That is actually miracle. It is not the case. You will not know. Population variance is also unknown ideally, right? How do you know? Are you getting my question clear? Hey, you people, if you are simply silent, then I can leave this class. Can you please respond to your roll number? I want to know who are present here. Simply, I cannot waste my time. Adi, Darshan, are you present?
Present, sir.
Then why you are not responding? Why your videos are off? Akash, are you present?
Yes, sir. Yes, sir. Yes, sir.
Then what happened? Why you people are not responding anything? Beula,
Present, sir.
what happened? You should be visible and you should at least respond, yes, I understand, so that I can proceed little bit. If you are silent, then no need of going through this class. Please respond. Even if you don't understand, you say no. My point is that here what I was telling for last 5 minutes, I'm spending time unnecessarily. I'm telling, assume there is a very big population. For example, a child with some disease, genetic disease in India. Do you think that all data is available? Maybe some 1 lakh, 10 lakh or 20 lakh child is there. Do you think that each and individual is known to you? No. If each and individual is not known to you, can you tell what is their average age mean of the population? Can you tell? No. If you don't know individually, can you tell their variance? No. So try to understand that we really don't know even mean also and variance also. So that's why I'm telling that the variance data is also not known, but assume now. Now I'm telling that from that population, I am having only 10 child, I am just collecting the data. So we are telling, we understand that sample mean X is not exactly same as the population mean. Do you agree that? If I'm collecting just 10, that will not be exactly same as that population mean. Yes or no?
Yes, sir.
Population is, for example, 10 lakh child. If I make an average, so for example, their average is coming 6.5 year. And I am telling, okay, you just take 10. So do you think their average will also be 6.5? No, something different. So we are going to say that we understand that it will not be same, and we are going to project on that. Sample mean mu x bar. So you understand the difference. When I'm talking about sample mean means 5, 10 sample or 20 sample, and then I'm taking x bar over bar, is not same as population mean mu. Population means very big. We don't know. For interval estimator, we make use of the probability distribution of the point estimator. Now I'm going to talk about how we are coming to know. Now question is different. What is the question? We already know the distribution. I already told that if the sample is having all are coming from a normal distribution, the sum of the element will be also normal. You remember? Then I also told the variance will be sigma square by n if it is an average. That I told you, right? If the member is, if I'm collecting some data from normal distribution, if they are adding those items, the sum will also be a distribution. It is not a constant number. It will be distribution, and its mean will be mu, and variance will be sigma square by n if I take average. So that concept I'm going to utilize. We already know that distribution of x bar will be normal with mean will be mu. Try to understand x bar distribution. Why x bar distribution? Because I may have different x bar. Are you getting my point? I can have a different x bar. If I take 10 sample from population, this 10, this 10, this 10, if I collect, they will be all different one. So that x bar is also a normal with mean of actual population mean should be its mean value and some variance. And the variance is sigma square by n. So that information I'm just writing. So what I can say? So x bar is a normal whose mean is mu. So I'm telling x bar is a normal distribution whose mean is mu and variance is sigma square by n. In our last class, I told any normal distribution, if I want to convert into standard normal, what to do? I told, if you remember, that the variable minus mu by sigma will be standard normal. I think before your holiday we discussed, and I hope you have not completely digested it. Something is there. Now coming into this part, your x bar is your variable whose mean is mu and variance is this one. So what will be in this case? What will be the standard normal? So we'll say x bar minus mu by what will be the sigma? Sigma means here sigma square is this one, right? For this variable, sigma square is sigma square by n. So what is sigma? Sigma by root n. Are you understanding?
Yes, sir.
Yes, sir.
Okay. Or I'll just take one slide so that confusion is not there. So I told what I told. Let me see. I'm telling this is a normal distribution of x, any variable. Then I told whose mean is mu and variance is sigma square. For that, I can say x minus mu by sigma is a standard normal. Now I am coming into a point where a distribution, the distribution name of x bar's distribution I am looking, whose mean is mu and whose variance, like sigma square part is, instead of sigma square, it is actually sigma square by n. Now how I am doing? I am doing x minus mu by sigma. So here what will happen? X bar, instead of x, it is x bar. Mu is same, here also mu. Sigma square variance, then I am using sigma. For this variance, I will take square root of this. Square root of this means sigma by root n. So this is known as standard normal. So that point only I told. If it is a standard normal distribution, then two things I can always tell. Standard normal distribution means this one. Now I want to know about confidence. So for example, this is a distribution of this. This is a variable. This distribution become a standard normal. For standard normal distribution, I can tell one important things. For standard normal, if I want to take 95% of the area, mean area, for example, then this value and this value, limiting values are known. Okay, this part and this part, this total area 9. So standard normal graph is fixed. I have shown you a standard normal graph few days back. For example, I want to take some 90% area, for example. So you know the area and I want to take mid area of 90%. So for example, I'm coming I'm telling this area is, anyway, you need not worry. This calculation is always available from table. So for example, this is 95% area. So can I say that my random variable, this is a random variable story. So this Z probability that it will be within this value. For example, this is minus 1.9 and for example, this is plus 1.9. So can I say that there is a 95% because I'm taking 95% of the whole area. I'm telling there is a 95% chance that my values will be within minus 1.9 and plus 1.9. Can I say in standard normal? I can say that my Z will be minus 1.9. So Z will be in between minus 1.9 and plus 1.9. That probability I can say is 95%. Am I clear to you what I'm speaking now?
Yes, sir.
Okay. If it is clear,
Yes, sir.
then I'll come. Okay. Nice. So after this, I'll come to my point of discussion here. Sorry. Oh, I have written so much. I'll just delete it. This one, right? No. Okay. So, okay. So coming to now this line is very important. What I'm saying the same thing. You see, first I decided that x bar minus mu by sigma by root n, or simply root n into this is a standard normal distribution. For standard normal distribution, I can make a comment. What comment I can make? I can say that probability of my this is Z, right? This is in between minus 1.96 and 1.96 is 0.95. That comment I am making. So you see, probability of my Z value, this in between, you have to speak, then only you can write. In between minus 1.96 and plus 1.96 is 0.95. Now, how they are arranging? That means probability that this one less than this and probability that Z will be less than minus 1.96. The same meaning or not? Do you understand this?
So can you say again, sir?
Okay, at least you tell that you don't understand. Even if you I'm a student, I will also not understand from this line to this line, but you are silent. Don't be. Let me come to this point. So I told this line is free, so I'm telling simply one line. I'm just describing here. I'm telling that probability of my Z, for example, I'm writing this is minus 1.96 and this is plus 1.96, and this value Z is the distribution, right? So what I'm telling probability that minus 1.96 less than Z less than 1.96, that I'm asking. So probability of this means I'm talking about this area, right? I'm talking about this area. I'm talking about this area. Can I talk this same thing in a different manner? What is the different manner? I want to say, why don't I say like this area as anything less than this minus less than this. I mean to say anything less than plus 1.96 minus this tail portion. Yes or no?
Yes, sir.
I'm talking about this area instead of talking about this area. Or for example, just simply say, I'm having some 80 and 60 and your marks. Okay. For example, your marks. So I'm telling probability that your marks is in between 60 and 80 is 50% chance. Your marks will be in between 80 and 60. I can just change it. I can say probability of your marks less than 80 minus probability of your marks greater than 60. I can say like that, na? Same way I am talking here. So probability of in between zone means probability less than the plus 1.96, the whole portion left side, minus probability of your value less than minus 1.96. That will give me the area what I am looking for. This point is very easy to understand. So what I can say instead of this, I can say this is actually probability that Z is less than 1.96. That means the whole backside area minus probability that Z is less than minus 1.96. Can I speak like that? Same thing I will be speaking. Whole area less than this minus area less than minus 1.96. This two concept is added here. So we are speaking only the same way. You see, probability this part less than this minus probability this part this. Now probability of Z less than this means I know probability that Z is less than 1.96. That value I can find out phi distribution, and this value is coming 0.95. If I'm not clear, I'm telling once again. So we are starting with this because I know probability of some value. If I'm going to my Z distribution, this distribution is there, na? I'm telling, tell me what is the area less than 0.19, this one. Then you can find out what is that. And then I'm having minus probability of your value less than minus 1.96. You can also tell that value. What is this value? That is actually phi minus 1.96. This is phi 1. Do you remember the phi value? In the beginning, before the semester, before your vacation started, we talked about that. Phi 1.96 means area. Phi 1.96 means area below 1.96, whatever area is coming. Am I clear? Area below 1.96, the whole area, that is called phi. Phi 1.96 means in standard normal distribution area less than this. So I'm just writing this is phi 1.96 minus phi minus 1.96. This area. Now instead of this, just people are just changing this way. Instead of this, I can say 1 minus, because this area and this area are symmetrical. So instead of this area, I can tell that this area, they are same. Now what is this area? This area is 1 total area minus less than this area. Yes or no? You people are
Yes,
so silent. So we are telling, first of all, what is phi 1.96? Means total area left side of 1.96. How I will get that? That I will get from my distribution table. Don't worry. You only remember this 1.96, this whole area. So I am having this is I am telling is phi 1.96. No issue. Minus phi minus 1.96, because Z less than minus 1.96 means phi minus 1.96. But unfortunately, in my table, what table is given to you in textbook, they do not talk about phi negative values. They only talk about positive. So phi minus 1.96 area finding from a textbook is difficult. So what is the solution? That means I am looking for this area right? Minus 1.95 minus 1.96 means I'm looking for this area. But in textbook, mostly they don't give. But no need to worry. This area, can I say, instead of 5 minus 1.96, is equivalent to this area also. This area and this area is same. Now, what about this area? How much is this area? Then question comes, this is equal to total area 1 minus anything less than this area, anything less than this point, yes or no? So first I am telling this area is equal to this area. Now this area equal to 1 minus anything left side. Anything left side means same, pi 1.96. So that's why I am saying, you see, 2 pi 1.96 minus 1, that is 0.95. So what can I say now? I can say there is this value, 95% chance if I need, then I can say this is the case, probability in between this and this. Now this will be just formalized, you see, now coming. So I can say that x bar minus mu sigma root n will be within minus 1.96 and plus 1.96 with 95% guarantee. Now, this thing I'm doing simple mathematics, nothing else. You see what I am doing? Minus 1.96 is less than this. Yes. Now what I am doing here? I am doing the same job, nothing new. What new? What things we are doing? I am multiplying everything by sigma by root n. Please try to understand. This is my expression. This expression I will be doing little bit mathematics. So probability minus 1.96 less than this thing is there, right? Root n x bar minus mu by sigma less than 1.96. Any expression. I mean to say, for example, if I say 7 less than x less than 9. If I say, if it is the case, can I do some small treatment with this one? Can I multiply something with this? For example, 7 multiplied 3, x multiplied 3, 9 multiplied 3. Do you think relationship will change anything? No. If 7 is less than x and x is less than 9, if I multiplied everyone with 3, this less than, this symbol will remain unchanged or not? Remain unchanged. 21 will be definitely less than 3x less than 27, right? So same thing, this fellow I will multiply with sigma by root n. So whole this fellow also I will multiply by sigma by root n. This fellow also sigma by root n. So what will happen? What does it happen then? That means probability, you see, it will become minus 1.96 sigma by root n. This will cancel. It is becoming x bar minus mu. It is becoming 1.96 sigma by root n. Just rearrangement. Now what I will do? I can do one small changes here. Now assume in both sides I am adding some value. What value I will add? This is the question. Now if I assume that, okay, for every case I will add or I will just subtract minus x bar. Minus x bar you subtract from everyone. Minus x bar. Do you think it will change the picture? Nothing will change. Behavior will remain same. Yes or no? Same thing subtracting. 7 less than something less than 9. So for example, 7 less than 8 less than 9. If I subtract 3 from each one, do you think that relationship will change? No. It will become 4 less than 5 less than 6. Yes or no? So same thing I am doing. So now what will happen? This x bar and this x bar will cancel. Yes or no?
Yes, sir.
Are you understanding these little steps? We started here and we are doing some small changes, some reason. I'll tell you the reason very soon. But how I am doing stepwise, because this was the relationship, minus 1.96 less than something less than this. Then what I did, I multiplied everyone by sigma by root n. If I multiply anything, any relationship, it will not change the behavior. It will remain less. This will remain correct. Then I am adding something with everyone, that is minus x bar. Correct. But what happens? Minus x bar, if I add with this one, it will cancel out some benefit. Yes or no?
Yes, sir.
Okay. Now, from this, I'm just factoring out minus. Here also I'm putting a minus factor. Here also minus is there. So now I'm asking you one question. You have to tell me. Minus 9, for example, it is minus 9 less than minus 3 and less than minus 1. This is correct or not? Am I writing? Is it correct? Minus 9 is less than minus 3. Minus 3 is less than minus 1. This is correct or not? Can anybody tell me? Simple question. Oh, any response?
Oh, correct,
Yes,
sir.
sir. Correct only, sir.
Simple thing I have written. Now if I say, okay, I remove all minus. Now this relationship will hold, correct or not?
Yes, sir.
It will remain, this symbol is correct now? Oh, you are not understanding my simple analogy. I'm giving you some examples so that you will understand. Minus 9 less than minus 3 less than minus 1. Everybody agree? Yes?
Yes, sir.
But in the relationship, if I remove the minus, everyone's minus, do you think the relationship is now correct? 9 less than 3 less than
No,
1, is
sir.
it true? No. But if I change the direction,
Then it will be right, sir. Greater
Correct,
than.
sir.
now it is correct. Same thing I will do here. You see, I factored out minus because everywhere one minus is coming. Then this minus I will remove. The factored minus I will remove. And I'll change the symbol. So what can I say? I can say x bar plus 1.96. So I'll say x bar plus 1.96 sigma by root 10 is greater than, earlier it was less than, mu greater than x bar minus 1.96 sigma by root 10. This statement is very interesting statement. We already made, we are already arrived, finished, nearly finished. What I can say? We are all done. I can say with 95, because it is a probability, what is there? Now you see, probability is still there. Probability, that statement is still there. What I'm saying? I'm saying now that some population mean will be greater than this value and less than this value with 95% confidence. Am I clear? So we already found out that, okay, population mean will be in between this and that. So I have written so much, readability is very difficult. So I'm just removing this and I'm coming. Okay, now it is going to finish now. So I done some these things. So what I can say? I can say that if I tell you now, very simple and final conclusion for this class. Next day onward, please move little bit faster. I am telling that I am having some sample. I am measuring, I am having 10 sample, 10 child and their weight is there. 8 kilo, 5 kilo, 4 kilo, or maybe I'm having only 4 sample and 6 kilo. Okay. And this is only sample I collected. I have only collected that the age of the, weight of the child is like this, having genetic disease. I am telling that India population mean, I don't know. But I am telling you the variance is, for example, variance, this means it is talking about population. Ideally, you should not know that, but I am telling, assume I know. Assume this is 2 kg. Then I am asking, tell me about mu. You tell me what is mu. Then you will be very easy to tell. What is this is sample, right? 8, 5, 4, 6. What is the average? What is the x bar? X bar means sample, average. 8, 5, 13, 13, 4, 17, 17, 6, 23, 23 by 4, 5.75. Yes or no? So I can say, you just write this 5.75 minus 1.96 sigma 2 kilo into 2 by root n. How many sample for me? 1, 2, 3, 4. Root n means root of 4 is less than mu, less than same thing, just it will be 5.75 plus 1.96 into 2 by 2. Anyway, 1.962 by 2 is anyway. So what is happening? Finally, I can say that 5.75 minus 1.96 is less than mu is less than 5.75 plus 1.96. So how much value is coming? It is coming 6. For example, 7.71 mu, it is, sorry, this is 7.71. And this is 4.7, for example. So what I can say,
3.7.
this is my last comment. My last comment is that the population mean will be in between 4.79 and 7.71 with 95% guarantee. My statement is over. Is it clear? That is called confidence interval. So if I know my population mean, I don't know, but variance I know for population, and I am having just 4 sample, then from that I can calculate x bar. I can calculate x bar, and then I can talk about the population mean mu. So mu means that is my achievement. I can tell from my sample, I can tell about the population. I can talk about the population. Yes, I can say that the child average mean weight will be within 4.75 and 7.75 at 95% guarantee. That is the stopping, because I think your learning curve is little slow. So I'm little slow at this moment. Now give me a summary. Do you understand what we have done today?
Yes, a little bit.
Yes, sir.
You understand, right? At least problem, when I have given this problem, example 8546 is the 4 sample I am collecting from child somewhere from hospital, and someone said that Indian population variance is 2 kilo. That you need to know, otherwise you cannot do. And then I am asking, tell me what is the mean weight of the child in India. That means I am asking about mean, and I am also asking you at 95% confidence. If I ask you the whole problem, now problem is there. Now if I ask you the same question, this problem came as 95% case. If I say you no, I want to know some other percentage, then what you will do? If I don't want to know this percentage, I want to know other percentage, then how can you deal this situation? So I took now area of 95, right? That time if I'm asking 80, then your 1.96 will not be there. Only change will be that. Please try to understand. Only change will be here. Instead of 1.96, because I was taking the whole this much area, only 5%, I skip the area. If I say 90%, then my picture will be different. So I'll take a little bit small portion. 80% confidence, then I'll take small portion. So my values of this boundary 1.96 will be something different. That is the only things will change in future. Anyway, I'm stopping this class in absence of your any encouraging response from you.
Sir, Abhinay and Pavitra were having some network issues. They were logged out. They're waiting for you to allow them.
No issue. Whom I can find out in video, I'll mark them only present at this moment.
Sir, they were having some network issues, so they were automatically logged out, sir.
Who are automatically logged out?
Pavitra and Abhinay, sir.
I'm admitting.
Yes, sir.
Now who are present? Can you please tell me? Whom I can see in screen, I will mark. So Adi present. Now your video is becoming on, right? Nice. Akash, what is your roll number?
Rani present, sir.
Yes, Adi. Akash, what is your roll number?
Sir, 10, sir.
10, sir. Akash 10.
Is it visible? I cannot see Akash.
Sir, he's having some network issues. Okay.
Okay. Now network rectified, I think. What you are doing, Akash?
Sir, in working in lab, sir.
Where you are doing?
He's in a lab, sir.
Labs.
Which lab?
Near
Switch
my
on your video, Akash. You switch on. Yeah. Where you are working?
sir, in my locality, sir.
That is fine, but this is your class hour. How can you attend a lab and do something?
Yes, sir.
Do you have permission for that? Huh?
Sir, no, sir. Just now, today only I joined, sir. So I should inform.
But why? Your class is still going on, right? You
Yes,
have
sir.
full length of class. Have you got permission from your mentor? Official permission for that? So
No, sir, I
please,
Yes,
no,
sir,
you
I
cannot
will
do
inform
like this.
today.
Please.
Yes, sir. I will inform today.
Yes. Avina present. Aman,
So yes, sir, present, sir.
Yes, sir.
I cannot see you. Beula present. Is it visible?
Present, sir.
Dhania present. Pavitra.
Present, sir.
Yes. Next. Fulla present. Kiran present.
Present, sir.
Krishna Kumar.
Present, sir.
Nelvin. Nidha.
Present, sir.
Nelvin. Nice. Pavitra.
Sir, Dhanyata.
Sir.
Dhanyata.
Pavitra.
Present, sir.
Shakti. Shakti. Sweta. I cannot find. Shakti. Absent.
Sir, roll number 17. Present, sir.
Roll number 17. We have not called you.
No, sir.
Okay. So who is absent from the screen and in this class? Likhit, which roll numbers are absent?
Sir, seeing, sir. 1 minute, sir.
Yeah.
Shanfar, sir. Muhammad Shanfar. And
I think that's all.
no, sir. Another one person, I think, sir.
You may please put in this chat box also, those who are present. Just one word. Just one word you put in this chat box. So it will be recorded.
Yes, sir.
Okay, fine. If you have written, then you may please leave this class, no issue.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, thank you, thank you,
Thank you, sir.
thank you, thank you all.
Thank you, sir. Thank you, sir.
Thank you, thank you,
Thank you, sir.
thank you, Likit. Bye.